Section 3 homework, here we go. So first problem, what we've got is we've got a 95 kilogram fullback running at 8.2 meters per second. Let me get a little bit better. All right, collides with 128 defensive tackle moving in the opposite direction. Both players end up with 0 speed. Okay, so we want the fullback's momentum. All right, so the P of the fullback equals the mass of the fullback, the velocity of the fullback. All right, so momentum of him is going to be 95 kgs times 8.2 meters per second. The momentum of the fullback, 95 times 8.2, that's going to be 779 kilogram meter per second of momentum. All right. All right, what is the change in his momentum? Okay, because he comes to a stop, the change, oops, sorry, gotta switch it over, right? Change in his momentum is actually going to be negative 779 kilogram meter per second. Okay, what is the change in the momentum of the defensive tackle's momentum? All right, so this one should be similar, 779 kilogram meter per second, because all of that momentum went into the D tackle. All right, what was his original momentum? Because he's going the wrong way, his original momentum should be 779 kilogram meter per second. And if you mess up the positives and negatives, I'm not too worried about that. All right, how fast were they going? All right, so we'll use the momentum of the D tackle equals the mass of the defensive tackle times the velocity of the defensive tackle. So negative 779 equals 128 kgs. This is going to be kilogram meter per second divided by 128. The velocity of the defensive tackle should be negative 6.09 meters per second. Again, if you are looking at directionality, that just means he's going the wrong way. If you had all positives, you're also super good at that, okay? 28 kilogram car is traveling at 20 meters per second. A 4,000 kilogram truck is traveling at 14.14 in the opposite direction. Thankfully, there are no drivers. Make-believe problem. They stick together after the epic crash. Okay, what is momentum of the car? So momentum of the car is going to be the mass of the car times the velocity of the car. So momentum of the car should equal 28. That's going to be kilograms times 20. That's going to be meters per second. 28 times 20. All right, that is 56,560 kilogram meters per second. All right. What is the momentum of the truck prior to the crash? All right. So P of our truck equals the mass of our truck times the velocity of our truck. All right, so P of our truck, the mass is 4,000 kgs times 14.14 meters per second. So 4,000 times 14.14. All right. Now, oops, sorry. That's going the opposite direction. So that's going to be negative 56,560 kilogram meter per second. Again, if you just want the magnitude of it, it'd just be 56,560. All right. Kinetic energy of the car. 1/2 mass of the car times the velocity squared of the car. All right, so 1/2, the mass of the car is 28. That's going to be kgs times 20 squared. That's going to be meters per second. So 0.5 times 28 times 20 squared. All right, that's going to be 565,600 joules. All right. KE of the truck. All right, that's going to be 1/2 times the truck's mass, which is 4,000, times 14.14 squared. Oh, I suppose we can make that negative. 0.5 times 4,000 times 14.14 squared. All right, so that equals 399,879.2 joules. All right, what is the total momentum prior to it? All right, so P total is going to be the momentum of the car plus the momentum of the truck, if it's the total. So P total equals 56,560 plus a negative 56,560. So the total equals 0 kilogram meter per second. Again, directionality matters there. What's the total momentum after the crash? Well, because they're both not moving, so V equals 0 for both of those. Let me rewrite that. So V for both equals 0. So our total momentum after the crash, or wait, hold on. I don't know that yet, do I? I just know that before the crash, it was, so P total before is equal to the P total after, which equals 0 kilogram meter per second. All right, so the velocity after, so the V of both after, right, is what we're looking for. So if I know the momentum total after, that's equal to the mass of both times the velocity of both, right? So this is 0 kilogram meter per second equals 2828 plus 4,000 times V of both. V of both equals 0 meters per second. All right, how much kinetic energy do the two vehicles have after the crash? All right, so after the crash, so we want the KE total after the crash, right? So after the crash, this will be 1/2 the mass of both times the velocity of both squared, right? So KE total 1/2 2828 plus 4,000, 0 squared. So KE total after 0 joules. All right, so how much energy was lost? Well, prior to the crash, so KE before was 565,600 plus 399,879.2 joules in joules. So 565,600 plus that other one, we got 965,479.2 joules energy, and that was lost. All right, so that would be a negative value. All right, what does this lost energy turn into? Heat, sound, maybe even a little bit of light. Okay.